The summer of 2001 essentially saw a new era in internet security with 3 major worm outbreaks. These 3 major worms were Code Red 1, version 2, Code Red 2, and Nimda. Let's take a quick look at each of these worms. Code Red 1 was released on July 13th, 2001, and was the first modern worm. It exploited a buffer overflow in Microsoft's IIS server. From the 1st through the 20th of each month, it would spread by finding new targets using a random scan of IP address space. It would spawn 99 new threads which generated IP addresses at random and then looked for vulnerable instances of IIS. Now, version 2 of Code Red 1 was actually released 6 days later and fixed the random scanning bug so that each instance of the worm scanned a different part of IP address space. After the scanning bug was fixed, the worm was able to compromise 350,000 vulnerable hosts in a matter of only 14 hours. By most estimates, that was the complete set of hosts running the vulnerable version of IIS on the entire internet. The payload of this worm was to mount a denial-of-service attack on whitehouse.gov, but a bug in the coding caused the worm to die on the 20th of each month. If the victim's clock was wrong, however, the worm would actually resurrect itself on the 1st. Fortunately, in this case, the payload which launched the denial-of-service attack on whitehouse.gov actually was launched at a particular IP address, not at the domain name. So the operators of the website needed only to move the web server to a different IP address to defend against the denial-of-service attack. A better worm design would have been much more catastrophic. Code Red 2 exploited the same vulnerability, but had a completely different payload. It was released on August 4th, 2001, and was called Code Red 2 mainly because of a comment in the code. The worm actually only spread on Windows 2000. It actually crashed on Windows NT. The scan actually preferred nearby addresses. It would choose addresses from the same /8 with probability 1/2, from the same /16 with probability 3/8, and randomly from the entire internet with the remaining 1/8 probability. The reason for preferring nearby IP addresses was that if there was one vulnerable host on the network, there was likely to be more, because the same administrator that failed to patch the compromised machine might have other machines on the same network that were also vulnerable. This notion of preferential scanning can speed up infections in some cases by increasing the probability that scanning will find another vulnerable host. The payload of this worm was an IIS backdoor, and the worm was completely dead by design by October 1st, 2001. Nimda was released on September 18th, 2001, and was interesting mostly because it spread using multiple propagation vectors. It was effectively multimodal. So in addition to using the same IIS vulnerability as Code Red 1 and Code Red 2, there were some additional vectors that it used. It could spread by bulk email as an attachment. It copied itself across open network shares. It installed an exploit code on web pages on the corresponding web server running on the machine so that any browser that visited the web page for that server would become infected itself, and it would scan for the Code Red 2 backdoors that worm had installed. The interesting thing about the multimodal nature of the Nimda worm is that signature-based defenses don't necessarily help. Because of the many ways that it could spread, for example, by email or via a website exploit, Nimda actually leaped firewalls. Most of the firewalls passed the emails carrying Nimda completely untouched. It was a brand new infection with an unknown signature, and thus scanners couldn't detect it. This was the first instance of a worm that exploited what we would call a zero-day attack, which is when a worm first appears in the wild, and the signature of the worm is not extracted until minutes or hours later. Zero-day attacks are particularly virulent because the worm can spread extremely quickly before any type of signature-based antivirus has a chance to catch up and prevent the infections in the first place.